So let's go through the bell work. Square root of 121. How does that simplify? 122. How does 122 simplify?
Doesn't it fully 11?
No, that's 121.
That's 121.
I couldn't figure out to do it. Hey, Casey.
So let's look at that. When we simplify it, we want to try to break it down. Can we cut it in half?
Yes, it's good.
It'd be 2 times 61. Can we break down 61 at all? Does 2 go into 61? Does 3 go into 61? Does 5 go into 61? 7? No. So this one does not simplify. This is not a perfect square. This is not a perfect square. I can't break either one of these down anymore to try to find perfect squares. So this one does not simplify. So what would I put for my final answer then if it does not simplify more?
No something.
No solution.
It's not no solution.
Just
Square root of 122.
Oh, so you just put it as it is.
You just leave it as itself. If you can't simplify it anymore, kind of like when we're combining like terms together, if there's no more like terms to combine together, we combine everything we can, and then we just write it as is. What about the square root of 24? Is that one a perfect square?
no.
Is there something times itself that would give you 24?
No.
No. So let's try to break it down.
6 times 4.
6 times 4, we could do that. Can we break down either one of those more?
Yeah.
So 6 would break down to be what? 3 times 2. Can we break down the 4 at all? 2 times 2. What's another way to write 2 times 2? What's another way to write 2 times 2 other than 4?
2 squared.
2 squared. So this would be 2 squared under my radical. Over here, I have 3 times 2 under the radical. What do we know about squares and square rooting? What happens when we square root something that's being squared? Cancels out. Do we have anything like that over here? No. Can I break down either one of those more? No, I cannot. So if I can't break them down anymore and I'm trying to simplify that radical, I would multiply them back together. So this would be square root of 6. But you said we could do this one. What's the square root of 2 squared? 2. So my final answer would be 2 square root of 6. You can do the birthday cake, yes. Here's what the birthday cake would look like with 24. You can only use prime numbers if you're going to use the birthday cake, which is one of the reasons why I don't show this one. But if you're used to the birthday cake, you're allowed to put 2, 3, 5, 7, 11. Those are numbers that can go on the outside. Only prime numbers. So if you can divide it by something else, you can't put it on the outside. What's a prime number that goes into 24? 2. What would that leave me with? 12. What's a prime number that goes into 12?
2 and 6.
2, and that would leave me with 6. What's a prime number that goes into 6? 2, and that would leave me with 3. What's a prime number that goes into 3? 3. And that would leave me a 1. That would be my birthday candle up on top. Yay! And then you look for pairs of numbers. So we can take out a pair of 2s. That's my 2 on the outside. These 2 don't have pairs. And so I would have to do 2 times 3 still under my radical, which is where this part comes from. So if you learned birthday cake last year, you can absolutely use birthday cake. All right. Last one on number 1. Square root of negative 49. What's the problem with this? It's got a negative under there. So this is going to be the square root of 49 times negative 1. So the square root of 49 times the square root of negative 1. You're absolutely correct that this is I. What about the square root of 49? Is that nice and pretty? 7. So my final answer here would be 7I. All right, last one, number 2. Evaluate the expression b squared minus 4ac, and then they gave us several different values to substitute in. What are we putting in the place of b? Negative 2. So I'm going to take negative 2 and square it. Minus 4 times, what are we putting in for a? Put 5 in for a. And what are we putting in the place of c? 7. Be careful here. Negative 2 squared. What is that? Negative 2 squared. Positive 4. So I have 4 minus, and now I need to multiply these pieces together. 4 times 5 times 7. 140. What is 4 minus 140? Negative 136. Beautiful. All right. So today we're only going to do 2 problems in your book. We're going to start off on page 177. We'll finish up on page 178. We're going to continue to practice completing the square like we worked on yesterday. First time through this problem, we're going to do it the way your book suggests doing it, which is by completing the square. Then I'm going to show you my shortcut method, and you can pick which one of those you like the best. All right? So page 177 in your book. We are going to be taking equations that are written in standard form, in ABC form, and we are going to convert them into vertex form, AHK form. When it's in vertex form, what is my vertex? HK. So once I have it in vertex form, I can pick out H and K. What kinds of transformations do H and K control? Left and right. H sends things left and right. What does K do? Up and down. What does A do to the graph? Wider or narrower, or it could do what? It can reflect it. So we have stretches, we have compressions, and we have reflections. That's reflections over the x-axis. Quick question before we get too far away from this and we actually get into looking at our equations. If I'm back here in standard form, ABC form, does anybody remember what C tells me? What feature from the graph does C tell me? An intercept. Which one? Y-intercept, yes. C value is our y-intercept. One last thing I want to point out. The A value in my vertex form is the exact same number as the A value in my standard form. These are going to be the same. So when I'm in standard form, I already know A. The only pieces that I need to go and find to put it into vertex form are H and K, because I already have A. If you look down here at this example, what's the A value on the standard form? 2. What's the A value on our vertex form? Right over here. It's also 2. Notice my A value stays exactly the same between these forms. Do you guys remember what we were doing yesterday when we completed the square? Which pieces did we work with? A, B, C. Which pieces did we want to complete the square? A and, not C, A and B. All right, we're looking at example number 9 in your book. I'm going to walk through it the way your book is saying, with a little bit of modification, because there's a couple things that I feel like your book just does the most confusing way. But I'm going to do it their method first, and then we're going to do it my method. And you can decide which way you like better. So since we want to work with just A and B, I'm going to block those 2 pieces off. Because here we've got A, B, and C. Is there a number in front of the x squared? -1. We need to get that out to the front because remember our vertex form, the form that we're trying to get it into, A is outside of parentheses. So I need to get A out to the front. So I'm going to take it out of these 2 pieces. I'm going to divide them both by -1 so that I can move it to the front. If I take -x squared and I divide it by -1, what do I have left? -x squared divided by -1. Positive x squared. What about a -12x divided by -1? I get positive 12x. And then we just have this -9 on the back. He just kind of keeps coming along for the ride. I'm looking right in here. This is where we're going to complete the square. So we need to figure out what we are going to add to make this a perfect square trinomial. But what are my rules? If I change something in an equation, if I do something to one side, I have to do it to the other side. So I'm going to have to do this to the other side. So far, so good? We need to figure out what is the value of C that will complete this square. How do I find that value? This is exactly what we did yesterday. Yes, take your B value, so this guy right here, divide it by 2, and square it. What is 12 divided by 2? 6. So I'm going to have 6 squared. And that's what I put right here. What is 6 squared? 36. If you do it to one side, you have to do it to the other side. Question, be very careful. What did we do to this side? What did we add over here? I added 36, but what's in front of these parentheses? -1 is supposed to get distributed to all these things, right? So over here, if I'm going to do the exact same thing to the other side, I need to take a -1 times this, because that's what I did to this side. So -1 times 36. My -1 came from here. My 36 came from here. All right. What is -1 times 36? -36. All right, I've got this -1 here. I have x squared plus 12x plus 36 here and minus 9 back here. Guys, I need you to pay attention, please. How will this factor? We just completed the square to make sure it would factor nice and pretty. How will this, what I wrote in blue, factor? X plus 6 squared, because it has to multiply to 36 and add to 12. 6 and 6, just like we did yesterday. The whole reason that we added the 36 there is so that it would factor to be half of my b value there. Out in front, I have a -1. Over here, I have y minus 36. And we still have this -9 back here. What's the last thing I need to do to this to get y all alone so that I have it written in this form here? Plus 36 on both sides. So I'm going to add 36, add 36. Y equals, I have a -1 out in front. Sometimes you'll just see that written as just a negative sign. Sometimes they'll put the -1, same exact meaning. What is -9 plus 36?
27.
Positive 27. Here it is in vertex form. What is the vertex? Be careful here. What is our vertex? Remember, it's HK, -6, and positive 27. Is that a maximum or a minimum? Does my parabola open up or open down? How do I tell? What is our A value? A value is right after the equal sign, so I'm looking right here. A is negative. Does it open up or open down if A is negative? Down. If you are feeling very negative about something, you're going to frown. So it opens down like a frown if A is negative. A is a negative number. Should write that as a lowercase. So this opens down. If my parabola opens down like this, is the vertex a maximum or a minimum? Maximum. Vertex is maximum. So the vertex that we just found, is that a maximum or a minimum? Maximum. All right. So that is a slightly tweaked version of the way your book did it. It is a lot of steps. Do you want to see my shortcut way of getting to the same answer but with less steps?
Please.
All right. Ms. Bolt's way. We still have a couple of steps, but not as many. And my shortcut way of doing this reaches back in my memory from what we did at the beginning of this section. So stuff that we need to pull back anyway, since your test is coming up next week. Be a really good idea to revisit these concepts. So what are the three pieces that I need to write it in vertex form? I need A, I need H, and I need K. All right, so things that I need. A, H, and K. If I know those three numbers, I can just plug them in, and then I have my answer. Do we already know one of these? Which one do we already know? We already know A. From our original equation, where do I see A? Where is A in this original equation? In front of the x squared. So what is our A value? -1. All right, so we have that piece. I need two more parts. H and K make my vertex, right? Yes? No? Vertex is HK. So if I can find the vertex, then I'll have the two pieces that I need. Does anybody remember how to find the axis of symmetry? Because the axis of symmetry goes right through my vertex, and it will tell me H. It gives me the x part of the vertex.
Is it up here?
Nope. We haven't done it in a while. Axis of symmetry is -b over 2a. X equals -b over 2a. Sorry, I forgot the x part. X equals -b over 2a. This will tell me H.
I knew it was that. But that's me.
Hold on. -b over 2a is how I find H. Trent, help me out. Original equation all the way back at the beginning. What number should we use in the place of b? I'm coming back here to our original equation. What number should I put in the place of b? Negative what? Not -2. Close. Look up here. -12. All right, so I have x equals, axis of symmetry formula starts with a negative. And then we're going to substitute in b, and b is -12. What goes on the bottom of my fraction here? 2 times -1, because our a value is -1. What happens when I have a negative times another negative? Becomes a positive. So I have a +12 over what? -2. What is 12 divided by -2? -6. What did we say the x part of the vertex was, doing it the other way? -6. Did I find the same h value?
Yes.
Yes. So now I've got 2 of the 3 pieces. A is -1. H I now know is -6. What's the last piece I need? I need K. Does anybody remember how to find K?
Don't you use
Yep.
6 and then add it or put it in for x?
We're going to substitute it in for x. So we're going to take this H, we're going to sub in for x to find K. All right, so I have y equals negative, and then I put my h value in of negative 6 squared minus 12. There's another x, so I put in another negative 6 minus 9. All we need to do now is simplify this, and then we'll have k. We'll have all the pieces that we need. What is negative 6 squared? 36. All right, so I have a negative, but then 36 from squaring this. What is negative 12 times negative 6?
Negative 72.
So close.
72.
Positive 72 minus 9. Can you guys pop all that into your calculators and tell me what you get? Negative 36 plus 72 minus 9. $27. Here's my k value. So where is my vertex? Negative 6, positive 27. Is that the same vertex that we got doing it the other way? Now, how do I take that and write it in vertex form? It is not in vertex form yet. H and K. Y equals, what am I putting in for A? Negative 1. X minus H. So X minus negative 6 squared. Sorry, let me write this in red real quick. There we go. Plus K, which is 27. But when I subtract a negative, that's the same as? Subtracting a negative is the same thing as?
Just adding.
Adding them, yes. So I would have X plus 6 plus 27. Did we get the same vertex form doing it this way? Guys, I need you to follow with me and pay attention. Did we get the same vertex form doing it this way? What was my vertex form over there?
Wait, did you drop the square?
Oh, no, I just forgot to write it down. Thank you for saying something.
All right, now, yeah.
Now I have the exact same vertex form. All right, I want to look at one last problem with you guys. Do you want to do it the book way or my way?
Your way.
Okay. Sounds like a plan.
I go over this.
Let's write it in vertex form first. Yep, it's the next page. It's not 177 anymore. I wrote the wrong number up here. Page 178. If I'm going to write it in vertex form, what pieces do I need?
B, A.
I don't need B. I need A, H, and K.
Sorry.
Do we know any of those parts? We know A. What is A? 3. This is A, so I have that already. A is 3. I'm still needing H and K. How do I find H? Yes. We're going to find our axis of symmetry. Axis of symmetry is x equals negative b over 2a. What am I putting in for b? Negative 12. Here's b. So I have negative, and then I put negative 12 in for b. Over 2 times what? 2 times 3. What happens here with the negative and the negative? Cancel out. So I have 12 over 6. What's 12 divided by 6? 2. What did I just find?
Axis of symmetry.
Axis of symmetry, which is which important piece of information? H.
Oh, H, sorry.
All right, so now I know that H is 2. How do I find K? Put H back into the original equation. So I'm going to have y equals 3 times 2 squared minus 12 times 2 plus 5. Sub in for x to find k. What is 2 squared? 4. What is negative 12 times 2? Negative 24. And then I have plus 5. What's 3 times 4? 12. So I have 12 minus 24 plus 5. How much? 17? I didn't get 17. 12 minus 24 would give us what? Negative 12 plus 5. Negative 7. This is my k value. So now I know all the pieces that I need. Help me write this equation. What does it start with? I heard somebody say y. Y equals 3, because we have our a value. Then what do I need? Parentheses. X minus or plus? It's x minus my h value. So x minus 2. Yep. Close my parentheses and square it. Minus 7. There we are in vertex form. Where is our axis of symmetry? Axis of symmetry. Remember, I need a whole equation. How do I write the equation?
Oh, you just run it past.
Yep. Not y equals, but x equals. Because when I draw that axis of symmetry, it goes straight up and down. So it has to go through the x-axis. X equals 2, because it's always going to equal my h value. Where is my vertex? So I need both pieces for my vertex. I need the h and I need the k. What's our h again? H isn't negative 2. H is 2. And what's k? Negative 7. Does this parabola open up like a cup or down like a frown? Up. How do we know? The 3 is positive. A value is positive. A is a positive number. So that means it opens up. So if I have a parabola that opens up like this, is my vertex a maximum or a minimum? Minimum. It's the lowest point.
Always the end point, isn't it?
Not the end point. It's either going to be your lowest or your highest.
Yeah.
Yep. Question. Can you describe what AH and K are doing to this graph? Start with H. How is H affecting this graph compared to the parent? Right 2. Down 7. Vertically stretched. So you can either use the completing the square method that your book showed. You can use the negative b over 2a, the axis of symmetry method, and then plug back in to find k. Yes, sir?
Now, if that 3 was, like, say, -3, would it be vertically compressed or would it still be vertically stretched?
It would still be vertically stretched, but it would also be reflected. So if your a value on the number line, to get to that number, to get to your a value, if you have to move more than 1 unit away from 0 in either direction, it's a stretch. If you are very close to 0 on either side of it, if you are within 1 unit on either side, that's when it's a compression. Yep.
If it's a negative and it's greater than 1, it's vertically stretched and reflected.
Yes. Yep. All right. That is everything we are covering for today. Your homework is due tomorrow. So based on what we did in class Friday and yesterday and today. So from Friday's lesson, you could do number 3, number 12, number 17. From yesterday's lesson, you could do the 6 in the middle, and now you can do those last 4. All right? Homework's due tomorrow.